2,000 meters beneath the surface. That's just 20% of the ocean's full depth. A warm-up act. We can go deeper, and what we find along the way, it defies belief, defies everything we thought we knew about life. At 2,000 meters, darkness is complete. No sunlight, no shadows, and yet the water glows. Tiny creatures flash in pulses of blue, red, green, a bioluminescent symphony where 90% of life shines just to survive. One of them, the abyssal dragonfish, no bigger than your hand, but with teeth sharper than a piranha's and jaws built for ambush, keeps sinking. At 3,800 meters, we pass the wreck of the Titanic, a monument to human ambition, now a rusted ghost swallowed by silence. At 5,000 meters, we enter the abyss, pressure so intense it should crush life, and yet life writhes on. At 6,000, we fall into the Hadal zone, where the weight of 335 elephants sits on every inch of your body, and still life exists. Then deeper, past where Everest would still not touch the bottom. This is where James Cameron went, where no light, no sound, no certainty survives, only pressure and the strange things hiding inside it. Prepare for a journey through darkness beyond comprehension. We begin. The ocean's surface is a lie. It glitters, it plays, it sings lullabies to children and carries the dreams of sailors across centuries. We walk beside it, float upon it, wade into it like it's just water, but we never really enter it, because what lies beneath is not just depth, it is descent, a slow, quiet fall into another world. Beneath the shimmering skin of waves is a chasm deeper than our tallest mountains, deeper than our oldest myths, so deep it defies the human brain's ability to imagine. We think of oceans as wide, but they are also crushingly vertical. They are not blue plates of water, they are inverted mountains, and falling into them is like falling through time. If you dive just 10 meters, your ears begin to ache. At 30 meters, your blood starts shifting. At 100, you can no longer rise too quickly without risking death. And yet, that is nothing. That is just the front porch of the ocean. 95% of the sea's volume exists in complete darkness. It begins where sunlight ends, roughly 200 meters down. And from there, you fall, slowly, quietly, inevitably. At first, it's still the ocean you know, faint light, fish that shimmer and dart, but then the blue begins to fade, not just darkening, but vanishing. There is a place where light no longer travels. It is not night, it is something else. The sea becomes thick and black and endless, and as you fall, sound fades too. There are no echoes, no crashes, just the low hum of pressure building, atom by atom, silence by silence. You are now entering the midnight zone. At 1,000 meters, it is colder than you thought water could feel. At 1,500, your lungs would collapse in an instant. At 2,000, you are just beginning, because 2,000 meters is only 20% of the ocean's deepest point, only a fifth. Yet already, no human body could survive. Already, the pressure is equal to stacking a rhinoceros on every square inch of your skin. Already, you are far beyond the reach of the sun and of certainty. And yet, there is life, tiny pulses of green, little dots of red, a rhythm of blue sparks. They float through the black, flickering like fireflies that lost their sky. You've entered the realm of bioluminescence, an evolutionary rebellion against the void. Down here, almost 90% of visible sea life glows, not for beauty, not for joy, but for survival. Light is bait, Light is camouflage. Light is confusion. A language written in flashes, spoken in ambush. Some flash to lure prey. Some flash to blind predators. Some emit a halo of light beneath them to erase their own shadow from being seen above. Down here, evolution doesn't just adapt, it reinvents. Eyes the size of saucers, mouths that unhinge like nightmares, teeth so transparent they're invisible until it's too late. One such creature, the abyssal dragonfish, a name too dramatic for its size, but its jaws 5 times sharper than a piranha's. Its fangs curve backward, so prey that enters can never escape. Its skin absorbs 99.95% of light, making it one of the blackest animals on Earth. Not to hide from predators, but to become the darkness itself. These are not monsters. They are survivors of the pressure world. Still, we keep falling. The water grows thicker, the cold more absolute, the light, even artificial, begins to fail. You are now surrounded by water that hasn't touched air in millions of years. There is no current here, no tides, only the slow, ancient churn of planetary stillness. And the deeper we go, the more reality bends. The ocean is no longer water. It is pressure. It is mass. It is a time capsule of the Earth's most extreme rules. But above all, it is empty, or it appears to be. That is the illusion, because in this quiet, in this blackness, in this silence, there are things, not many, but they are there. Things that have no eyes because they do not need to see. Things with no pigment because there is nothing to reflect. Things that move slowly because fast means death when energy is scarce. And yet, they persist. The ocean's depth is not sterile. It is stubborn. It is proof that life doesn't just find a way. It insists. It insists on breathing, even when breath is crushed. It insists on glowing, even when no one is there to see. It insists on motion, even when the world says, still. Back at the surface, we look out at the sea and see a playground. We swim, we surf, we sail, and we tell ourselves that we know the ocean, but we don't. We know the top. We know the shallow skin that lets in light and lets us float. We do not know what lives 11 kilometers beneath. We do not know what breathes in the Hadal zones. We do not know what waits in trenches deeper than Everest is tall. We have maps of Mars more detailed than the floor of our own oceans. We've walked on the moon. We've sent probes past Neptune. And yet, the deepest parts of our own planet remain unexplored, not because they are far, but because they are forbidding. They are not just below, they are beneath understanding. To dive that deep is to abandon the world as we know it. To descend is not just to explore, it is to disappear into something alien. And still, we go. We send machines, we send men. We listen for echoes in silence. We shine lights into nothingness and watch for a flicker that flickers back, because something is down there. And this is where we begin. At 2,000 meters below the surface, you are no longer falling through water. You are falling through memory, Earth's, not yours. Because down here, the rules that shaped surface life no longer apply. There is no sunlight, no photosynthesis, no warmth from the sun's mercy. Yet something glows. Tiny points of light blink through the black like distant stars. Only these stars move. They drift. They hunt. They communicate. This is the bioluminescent zone, a hidden theater where almost everything that lives also shines. 90% of known deep-sea species, each with their own language of light. Flash, pulse, glow, light. In the deep is survival, a decoy, a trap, a warning. Here, vision has evolved beyond seeing. It has become weaponry. The dragonfish swims like a shadow with intent, small but terrible. Its body is soft, flabby. Pressure won't let muscle build like it does above, but its teeth, glass-like, needle-thin, sharper than steel, and invisible until it's too late. Its lure glows just beneath its jaw, a faint pulse of green that beckons curious prey, a flicker in the void, then gone, and its skin, black like the absence of thought. It reflects no light. It eats light, becoming a silhouette of nothing. This is not death, it is adaptation, because down here, every photon is sacred, every breath is an inheritance, every heartbeat is an act of resistance. In the upper ocean, life is colorful and fast. It dances in currents, photosynthesizes in sunlight. But here, life has become minimalist, stripped down, built only for function. A squid flashes red to confuse its hunter. A jellyfish blooms like a ghost, glowing gently as it drifts past, its tendrils trailing light like smoke. Some creatures have evolved to use light as camouflage. Counter-illumination, it's called. They shine a soft light from their bellies, matching the faint glow from the surface above. To anything watching from below, they simply vanish. Others light up only when disturbed, triggering a burst of brightness like a marine flare, enough to startle, to blind, to flee. Because down here, everything is hunting, and everything is hunted. There are no plants here, no coral reefs, no kelp forests. Instead, the seafloor is flat and fine-grained, a soft gray desert. Volcanic ash and the slow, steady snow of dead things drifting from above. It's called marine snow, a quiet rain of decaying particles, fecal pellets, tiny carcasses. It's all that feeds the deep, a slow, drifting apocalypse turned into sustenance, and still, from that, life emerges. At this depth, pressure is over 200 times greater than at sea level. To imagine it, take a soda can. Now place a truck on top. That's what every inch of your body would feel if your body could make it here. But it can't. Your lungs would collapse. Your bones would fracture. Even reinforced submarines begin to groan from the strain. Yet here swim creatures with no armor, no bones, no shells. Just gelatinous bodies designed to bend, not break, to yield, not resist, because in the deep, flexibility is strength, and still, we know almost nothing about them. We drop cameras, send probes, but only for minutes, sometimes hours, rarely long enough to watch behavior, to understand their relationships, their migrations, their fears. They are born and die without names, whole ecosystems, entire species, unknown to science, unknown to us, and yet they are part of our world. One of the most haunting things about the 2,000-meter mark is not the darkness, it's not the pressure, it's the silence. Sound travels differently here. Low-frequency calls might span miles, but most creatures do not call, they do not click or chirp or sing. They wait, they watch, they survive. Imagine floating there, inside a submersible, lights off, engines silent, just the creaking metal of your capsule and the occasional drift of a glowing thing passing by, utterly indifferent to your existence. You are not in your world anymore. You are in theirs, and they do not care for your eyes, your thoughts, your theory. It is here in the darkness that human awe meets its limits. We can map it. We can measure the pressure. We can catalog its species, the dragonfish, the gulper eel, the comb jelly, but we cannot feel what it means to live here. We cannot imagine evolution's slow choreography, how millions of years shaped a world of floating ghosts and self-lit predators. We fall, we observe, but we remain guests, always guests. Back above, ships pass overhead, their hulls slicing the surface like razors across skin, and they have no idea. that 2,000 meters below, a civilization of light and silence exists, not waiting to be discovered, but content to remain hidden. Because the ocean does not care if we see it. The deep does not care if we understand. It simply is, silent, sovereign, unreachable, except by those willing to fall. There is a graveyard in the deep, and it holds more than bones. At 3,800 meters beneath the surface, nearly 4 kilometers down, the Atlantic Ocean swallows a monument of metal and pride, the RMS Titanic, a ship once called unsinkable, a cathedral of steel, a floating palace built to tame the sea. Now it rests quietly in the dark, split in two, its hull torn open like a wound, not buried, not forgotten, but preserved by the cold, the pressure, the silence. A century has passed since that night in 1912, and yet, down here, time does not move the same. There is no weather to erode the iron, no scavengers to chew the wood, only slow chemistry, slow rust, and a silence thick enough to hold grief. When explorers first reached it in 1985, the Titanic was intact, almost surreal in how still it sat, bow pointed slightly downward, as if still trying to complete the journey. But it was already being consumed. Tiny iron-eating bacteria, invisible to the eye, had made a home of its hull. They built rusticles, delicate, icicle-like structures of decay, silent, beautiful corrosion, a feast of metal and memory. These bacteria do not sleep, they do not stop, and slowly they are turning one of history's greatest engineering feats into dust. At this depth, pressure exceeds 380 times the atmosphere at sea level. The steel walls of the Titanic, so formidable above, mean little down here, because in the deep, the ocean always wins. Even the mightiest fall, even our greatest creations dissolve. And so, the Titanic is not just a shipwreck. It is a lesson, a reminder that we are not permanent, that even our monuments vanish in the weight of water and time. There are shoes scattered across the silt, pairs of leather, untouched by decay, marking where bodies once rested before being claimed by the deep. Fabric gone, bones long dissolved, but the shoes remain, soft, eerie reminders that this is not just a wreck site, it is a tomb. Human lives ended here, not in fire or war, but in cold, breathless surrender to the sea. And in that, the Titanic connects us to the deep in a way science cannot. Because it is not alien, it is not glowing or predatory or strange. It is us, human ambition, human tragedy, human vulnerability, preserved 3,800 meters below the surface. When cameras return to this site, they do not find silence, they find stories. A porcelain doll's face, unbroken, a wine bottle, still sealed, a chandelier tangled in seaweed, still shimmering when the lights pass over it. These are not just objects, they are echoes, and the sea holds them gently, not out of mercy, but out of indifference, because the ocean does not mourn. It preserves, it absorbs, it erases names, but never entirely the presence. The water here is just above freezing. The darkness is complete, and still, life swims past. Not in tribute, not in fear, but simply in passage. A ghostly squid, a shrimp with glowing eyes, a rat-tail fish nosing along the debris. To them, this is not a grave, it is a reef. Because in the deep, even tragedy becomes ecology. Even our mistakes become someone else's shelter. And so we must ask, what else lies forgotten at these depths? What other vessels, ambitions, failures sit in the cold, unseen archive of the seafloor? Submarines lost, aircraft pulled down by storm, weapons, waste, and the drift of human detritus that sinks and disappears from view, but not from existence. The ocean keeps secrets. more than any vault, more than any sky. And unlike land, there are no grave markers, no weathered stones, no names etched in marble, only silence, only pressure, only the slow rust of memory. And yet, we go back, explorers, engineers, filmmakers, scientists. We return with ROVs, with submersibles, with light and breath held tight, because there is something sacred about this wreck, something humbling. It reminds us that beneath every voyage, every invention, every claim of mastery over nature, there is always risk, there is always the unknown, and beneath all of it, there is always the deep. The Titanic's resting place is more than a history lesson. It is a threshold, because once you reach 3,800 meters, you are closer to the average depth of the ocean than to the surface you came from. You are past the point of rescue, past the reach of light, past human certainty. From here on, you are descending not just into geography, but into something more profound. You are descending into a realm where the human story no longer dominates, where the sea writes its own chapters, in pressure, in silence, in the slow turning of shipwrecks into shadows. And so we sink deeper, past the ghosts of steel and story, into the zone that defines the ocean itself, the abyss. At 5,000 meters below the surface, we enter the abyssopelagic zone, known simply as the abyss. The word comes from ancient tongues. Greek, abyssos, bottomless. Not just deep, but infinite. Not just far, but unknowable. It's a name humans gave long before we ever touched this depth, before we could measure it, before we even knew it existed. We feared it, because something in us understands that the abyss is where the world stops being ours. At this depth, sunlight is a distant memory. The pressure is 500 times what you feel on land. That's like balancing 2 semi-trucks on your thumbnail. No light, no warmth, no mercy, and still life. But not life as we know it. Not colorful coral or darting fish. Here, life is strange, slow, and often still. The creatures that inhabit the abyss don't thrive, they endure. Imagine a jellyfish the size of a human, drifting without purpose, not hunting, not fleeing, just surviving. Its body glows faintly, its nerves react slowly. It doesn't have to rush, because here, time itself feels slower. Near it, an abyssal sea cucumber inches along the sea floor, translucent, mouth gaping wide to gather fallen particles of marine snow, a scavenger of decay, turning detritus into life. And somewhere in the silt, an abyss crab moves, its spindly legs clicking softly against rock. It's blind, pale, perfectly adapted to a place where sight is useless and touch is everything. Here, even the water behaves differently. It's denser, heavier, pressed into a kind of stillness, a slow churn, barely moving across centuries. There are no waves in the abyss, no tides, no storms, just silence and weight, and the occasional flicker of something alive threading between particles of ash and time. The average depth of the global ocean is around 3,688 meters, but vast portions are even deeper. 5,000 meters is where the abyss becomes common, where the ocean's true nature is revealed. We often speak of the sea as a surface, but in truth, the sea is a volume, and most of that volume is this: a silent, sunless world that stretches for thousands of kilometers across trenches, ridges, and plains. To map it is to map mystery, and most of it remains unmapped. What lives here is not only strange, it is scarce. Food is rare, energy is minimal, and the ecosystem runs on conservation. Move slowly, eat everything, evolve carefully. A wrong adaptation here is a death sentence. There's no second chance. But those that make it those that survive for millennia. They carry the secrets of ancient oceans in their blood. Some species here have changed little in 100 million years, living fossils, perfect designs for a place that punishes change. And yet, even here, we've begun to leave our mark. Plastic has been found in the guts of abyssal creatures, fibers of synthetic clothing drifting down, settling in sand that has never known sunlight. Our noise reaches too: seismic testing, sonar pings, mechanical thrums. The quiet is no longer absolute. Even in the abyss, humanity is arriving. And so the question becomes, how do we meet this world? Do we explore it with reverence, or do we exploit it with ignorance? Because the abyss is not empty. It is not nothing. It is not dead. It is the majority of Earth's living space, a biosphere that dwarfs the land above, and it has been running its own ancient systems since long before we walked upright. Inside this cold, crushing world, there are things we still don't understand, things that baffle biologists, things that rewrite what we thought life could be, like abyssal gigantism, a strange trend where deep-sea species are often far larger than their shallow water relatives. Why? We don't fully know. It could be pressure, cold, the need to travel farther for food, or just the way evolution works when no one is watching. As you drift through this zone in a submersible, your lights catch flashes of strange geometry: a jellyfish with spiral arms, a worm that glows in red, then vanishes, a fish with a face that looks almost expressive. You begin to feel small, not just in size, in knowledge, in time, in understanding, because this place doesn't just challenge our science, it challenges our scale. We spend our lives on the skin of the world, but this is its body, its heart, its oldest story. And the pressure here, it becomes something else, not just physical, but psychological. Even inside a sealed vessel, you feel it, in the silence, in the way the metal groans, in the way the dark seems to lean closer, as if listening to your breath. Many deep-sea researchers speak of a strange unease, a low-grade fear, not of what they see, but of what they don't. Because down here, you begin to realize you're not at the bottom. There is still more, still deeper. The abyss is not the end. It is the beginning of the next descent. And so we press on, through the stillness, through the dark, into the deepest parts of the planet, where no sunlight has ever touched, where pressure is unimaginable, and where, somehow, life still flickers. Welcome to the edge of the Hadal Zone. We've crossed a line now. At 6,000 meters, we leave the abyss behind and fall into a zone that few even dare to name, the Hadal Zone. Named after Hades, the Greek god of the underworld, a place of myth, of finality, and for Earth's oceans, a real place. It exists in only the deepest trenches and subduction zones, and it is unlike anything else on this planet. The water here is so cold, it barely hovers above freezing, 1 to 4 degrees. It's so still, it feels motionless. And the pressure, it's no longer metaphor, it's math. Over 1,100 times the atmospheric pressure at sea level. To stand here, if you could, would be like carrying 335 full-grown African elephants on your shoulders. And titanium creaks here, even engineered steel warps. Your heartbeat slows, not from fear, but from awe, because you're no longer just deep underwater. You are inside the crushing silence of Earth's most remote biome. And yet, here too, there is life, not in abundance, but in extremity. Here, the organisms are called extremophiles, not because they like the extreme, but because they endure it. Some of the world's strangest creatures reside here, and some we've only ever seen once. The Hadal snailfish, for example, a a ghostly, transparent creature with no scales, fragile bones, and skin so thin you can see its organs pulse. It survives by being delicate, soft-bodied. It lets the pressure pass through it rather than resisting it. Strength here is not brute force. It's surrender. And then there are the giant amphipods, shrimp-like scavengers, bright white or translucent, some the size of a human hand. They feed on whatever falls, a whale corpse, the remains of a squid, or even microplastics. Yes, even here, we've left our fingerprints. In 2019, scientists found plastic fibers in the guts of Hadal creatures. In the deepest point on Earth, they are eating our trash. But it's not just creatures that haunt these depths. It's silence, real silence. Not the absence of noise, but the presence of stillness. No waves, no current, no sound but the distant creak of your submersible and your own breath. In 2012, James Cameron descended to 10,898 meters in the Mariana Trench, the deepest solo dive in history. He called it a lunar desert. No light, no movement, no life, at least none he could see. But the silence stayed with him, because silence, down here, isn't empty. It's ancient. It's weight. The Hadal Zone is rarely explored, not just because of depth, but because of danger. Pressure like this doesn't forgive mistakes. A single leak in a submersible, and steel implodes like paper. The cost is high, the risk is absolute. Only a handful of expeditions have dared come here, and even fewer have returned with data. But what they've found challenges everything. Bacteria that metabolize hydrogen, microbes that feed on stone, viruses that infect even the smallest archaea. Some of these organisms haven't evolved in millions of years. They live in pitch dark, eat chemical energy, and reproduce in a world without seasons. They are alien, not because they come from another planet, but because they might as well have. We don't know how they survive. We barely understand how they were born. Yet they thrive in conditions that would kill any surface life in seconds. The Hadal trenches themselves are geologic scars, formed by subduction, where tectonic plates crash and one is forced beneath the other. These trenches are deep wounds, cutting 11 kilometers into Earth's crust. They are graveyards, nurseries, mystery vaults. Entire ecosystems exist within a single trench, some never seen by humans, some never will be. And if that weren't enough, the Hadal Zone is constantly shifting. Unlike the calm above, the trenches move. Earthquakes, volcanic activity, sediment flows that last hours, carving new valleys we will never map. It's not a static world. It breathes slowly, violently, and it reminds us this is not our world. It was never built for us. We are intruders here, visitors, clutching lights and steel hulls, trying to glimpse what should remain unseen. But we look anyway, because to look is to wonder, and to wonder is to be human. So as we descend past 6,000 meters, remember, you are entering a domain where no light has ever shone, where time crawls and pressure reigns, where life has adapted not to live, but to endure the unendurable. This is the Hadal Zone, and it goes deeper still. At this point, we're no longer explorers. We're phantoms, drifting where light has never dared, and life, if it exists, has rewritten the rules of biology. Are 7,000 meters deep and still falling. Here, the ocean is no longer a place. It's a force, a pressure that shapes everything, from bone to biology to silence itself. We've entered a region so remote, so crushing, it has been called the inner space of Earth. The creatures here, they're not just strange, they are spectral. The supergiant amphipod, for instance, a ghost-like crustacean with translucent armor and antennae that twitch like radar dishes. You might think it's a myth, but it's real. In 2012, researchers from the University of Aberdeen found them at nearly 7,000 meters. More than 10 times larger than a typical amphipod, these giants look like something left behind from another epoch. They glow faintly, not to attract, but to warn. Nothing down here moves without purpose. Go deeper, 8,000 meters, and the water becomes more than black. It becomes textureless. Your lights don't pierce it, they smear across it. You're in a fluid darker than night and colder than bone. And then something moves. Not fast, not dramatic, just a slow, flickering pulse. The hadopelagic jellyfish, rare, red-limbed, and softly bioluminescent. It swims not to feed, but to drift, as if even effort is too costly down here. Its body is 95% water and nearly neutrally buoyant. It doesn't fight the deep. It yields. And at these depths, movement is memory. Even the smallest touch leaves traces for hours. A crab's scuttle kicks up dust that doesn't fall back for a day. There is no current strong enough to clean the past. The ocean here remembers everything. The trench walls are steep, cloaked in fine sediment, and scoured by gravity-driven avalanches called turbidity currents. These can collapse entire slopes in slow-motion chaos, carrying bones, silt, ancient whale falls, and even microplastics into the ultimate graveyard. Nothing escapes. And there's life. It's just not what we expect. In 2020, scientists discovered a tiny amphipod species in the Mariana Trench with plastic embedded in its tissues. They named it Eurythenes plasticus. Its very name now marks the scar of our presence in the deepest silence of Earth. Some trenches, like the Tonga Trench, are even deeper than we once believed, and some carry clues to Earth's early past. Within their rock samples, we find isotope, minerals, and microbial fossils that predate complex life itself. These aren't just trenches, they're time machines. But even as we study them, we know almost nothing. For comparison, we've mapped more of Mars in high resolution than we have of our own ocean floor. Only 3 people have ever been to the deepest point, and we still can't say for sure what lives in every trench. We are now brushing the edge of 10,000 meters. That's 10 kilometers, 33,000 feet. That's the altitude of a commercial airliner, but flipped. Instead of soaring, we are falling into weight, into quiet, into a darkness that stretches reality. Submersibles at this depth creak. Even thick titanium bends ever so slightly. A single miscalculation in pressure control, and the craft would collapse in an instant, imploding with no warning. There is no margin for error here, but the reward? Moments like this. A ghost octopus, pale and unblinking, drifting gently over the sediment. Its arms spread in slow waves like pale flags in the currentless dark. Discovered by NOAA in deep Atlantic waters, it's been nicknamed Casper. It has no pigment, no ink sac, no camouflage. Why would it? Down here, there is nothing to see, and still we press deeper. Not just to find monsters, but to find truth, to ask how life can persist in places of impossible pressure, and maybe to understand how it might exist beneath the icy oceans of Europa or the methane lakes of Tie. And because if life survives here, then life could survive there. The journey through 7,000 to 10,000 meters is not just descent, it's disappearance. A slow fade into realms that rewrite our assumptions about biology, geology, and time. We are passengers in a zone where every heartbeat echoes like thunder, every movement leaves ripples that last for hours, and every discovery humbles us. Next stop, the bottom of everything, where no light has ever been, where human voices have never echoed, where the earth becomes something else entirely. 10,984 meters. That's the deepest known point in any ocean on Earth, and it has a name, Challenger Deep. Tucked within the southern end of the Mariana Trench, this abyss lies beneath the Pacific, just east of the Philippines and south of Japan, yet might as well be on another planet. Because here, at nearly 11 kilometers straight down, the rules of Earth begin to bend. It was first measured in 1875 by the HMS Challenger using a simple weighted rope. The reading stunned the scientific world, but no one could go down there, not for nearly a century. Then, in 1960, two men did the impossible. Don Walsh and Jacques Picard boarded the Trieste, a specially designed bathyscaphe shaped like a deep-sea drop of mercury. It took them nearly 5 hours to descend. As they dropped, metal creaked, viewports fogged, and the pressure outside grew to over 1,000 times what we feel at sea level. That's like balancing a skyscraper on your head. And then they touched bottom. What did they see? A flat, featureless plain of pale sediment, like the floor of a desert. And astonishingly, a fish, a flat-bodied creature fluttering away in the dust. It shouldn't have been alive there, and yet it was. For decades, no one returned. Not until 2012, when filmmaker James Cameron, yes, the Titanic director, descended alone in the deep-sea Challenger submersible. He reached 10,908 meters. He called it a lunar desert. No light, no movement, only the groaning of his sub as it fought against the unbearable pressure. He stayed there for 3 hours, long enough to collect samples, film the terrain, and return with one truth. It was the most isolated I've ever felt in my life. So what exactly is down there? We expected nothing, but we found something. Microscopic life exists in the sediment, even at this depth. Tiny organisms called piezophiles, pressure lovers, thrive here. Their cell membranes are built differently. Their enzymes work under stress that would obliterate most known life. They survive without sunlight, without warmth, without rest. Some scientists now believe such microbes could be the most ancient survivors on Earth, descendants of life forms that thrived billions of years ago in Earth's earliest oceans. But it's not just biology that hides here, it's history. The trench floor is littered with relics that should not be this deep. In 2018, researchers captured footage of a plastic bag drifting across the sediment at 10,900 meters, the deepest piece of human trash ever recorded. Even here, we have left fingerprints. And then there are the sounds. Recordings made from hydrophones at the trench's bottom have captured strange low-frequency rumbles and moans, some natural, some unexplained. We don't fully understand how sound travels at these pressures through such dense water, but what's certain is this: the deepest part of the Earth is never completely silent, and the trench itself, it's alive in its own way. The Mariana Trench lies at the boundary between two massive tectonic plates, the Pacific Plate and the Philippine Sea Plate. As one slips beneath the other, it causes earthquakes and creates new seafloor. The very act of subduction, one plate being swallowed by another, creates the trench's impossible depth. So even as it rests in silence, the earth beneath it is shifting, groaning, and alive. And still, we've barely scratched at the surface. There are deeper pockets, hidden crevices, and side trenches that remain completely unvisited. We suspect some reach down to 11,034 meters or more, but we can't confirm them because even with all our technology, going that deep remains nearly impossible. Pressure isn't the only obstacle. There's darkness so thick it consumes lasers. There's silt so fine it clogs robotic sensors. There's temperature gradients that mess with electronics, and unstable currents that can flip a submersible like a toy. It's like trying to explore a cave at the bottom of an alien planet with a blindfold on and only minutes of oxygen. And yet, we return. Why? because what we learn here rewrites what we know about life. In Challenger Deep, we find resilience beyond comprehension, life not just enduring, but evolving to thrive under the most hostile conditions imaginable. It gives us a glimpse, not just of Earth's past, but of its possibilities, of life under Europa's icy crust, of alien oceans beneath Enceladus or Titan, of how life adapts to anything, if given time. Challenger Deep isn't just a trench, it's a mirror, one that shows us how little we truly know, one that humbles us, because even after reaching the bottom, we're left with more questions than answers. The deepest dive is not an endpoint, it's a beginning, a threshold to a world we haven't yet understood, a world that hides its truths in pressure, darkness, and silence, and it dares us to look deeper. At nearly 11 kilometers below the surface, the water changes, not in color because there's no light, not in pressure because it's already maxed out, but in chemistry. Here, in the deepest pockets of the Hadal trenches, life isn't just surviving, it's running on different rules. This is a world where oxygen is scarce, where temperatures hover barely above freezing, where even carbon, life's building block, circulates in strange forms, and somehow organisms still persist. Take barophilic bacteria, for example. These microbes don't just tolerate high pressure, they require it to function. Remove them from the crushing weight of the deep ocean, and they literally fall apart. Their enzymes are like biochemical origami, folded to perfection only under thousands of atmospheres. These same enzymes, stripped from the creatures they evolved in, are now being studied for their industrial use on the surface. In medicine, in food processing, even in molecular engineering. Then there's methane, pockets of it, sealed beneath sediments for millennia, slowly seep into the water. At these depths, methane doesn't rise, it clings. And around these slow, silent leaks, strange communities emerge. Not coral, not fish, but colonies of chemosynthetic life, bacteria that digest methane and excrete compounds other creatures feed on. It's an ecosystem built without sunlight, without plants, without photosynthesis. It's alien, but entirely Earth-born. Now pause for a second. Think about that. A fully functioning biosphere, thriving off methane and minerals, in total darkness and crushing pressure. And now shift your gaze outward, to Europa, the frozen moon of Jupiter, to Enceladus, Saturn's icy satellite. Both are believed to have liquid oceans beneath their frozen shells, and both show signs, thermal vents, plumes of water vapor, organic molecules, of possibly harboring life. But we don't need to guess what that life might look like, because we're already seeing it here, 11 kilometers beneath our own seas. Hadal chemistry is prebiotic chemistry, the kind that may have seeded the first life forms on Earth 4 billion years ago. The deep sea isn't just ancient, it's primordial, and some of the substances we find here aren't made by organisms at all. They're forged by heat, pressure, and time, like clathrate hydrates, crystal cage of ice that trap gas molecules inside them. They form under conditions found only in deep trenches and alien moons. They hold secrets, frozen methane, xenon, even trace compounds no one can explain. If released, these gas pockets could destabilize ocean chemistry or hint at entirely new elements of Earth's carbon cycle. Then there are the minerals. At Hadal depths, sediments absorb heavy metals like a planetary filter. We find layers of manganese nodules, rare earth elements, and even traces of radioactive isotopes that date back to atmospheric nuclear tests. The deepest sea isn't just old, it's a library of human activity cataloged in invisible ink. And still, we don't know most of what's happening down here. Every time we send down a probe, we discover something unexpected. A new species, a strange chemical, a reaction that defies the textbooks. In one trench expedition, researchers found arsenic-based microbes thriving in poisoned sediments. In another, life forms whose fatty membranes shouldn't remain stable at these temperatures, but do. Even viruses behave differently at these depths, adapting to the pressure with mutations we've never seen before. Why does this matter? Because the more we learn about Hadal chemistry, the more we realize that Earth is not a closed system. The boundaries of habitability are wider than we imagined. And every one of these discoveries makes extraterrestrial life feel a little less improbable. If life can thrive in high-pressure, methane-rich, lightless trenches with limited oxygen and no photosynthesis, then why not beneath Europa's ice? Why not in the subsurface lakes of Mars or inside Titan's hydrocarbon seas? We are looking at mirror worlds. Alien oceans are not theoretical anymore. They are reflections of what we've already seen. And Hadal life, tiny, pressure-loving, chemically fearless, this may be the blueprint for our first contact with biology beyond Earth. So every time a robotic arm collects sediment from a trench wall 11 kilometers down, we're not just studying this planet. We're studying many planets, the ones we haven't reached yet, the ones that might carry life, not so different from the strange, glowing, pressure-warped creatures we already know. The chemistry of darkness is a chemistry of hope, because it tells us life doesn't need light to begin. Only time, only pressure, only the right molecules, and the silence to rearrange themselves into something that breathes. At these depths, the ocean ceases to be water. It becomes silence incarnate, a crushing, frozen, endless expanse where time stretches, light dies, and life transforms into things we were never meant to see. Welcome to the abyss. More than 6 kilometers below the surface, sunlight isn't just absent, it's forgotten. Here, day and night are meaningless. The stars are blocked by miles of pressure, and the surface might as well be a distant planet. And yet, in this place where light has never reached, light is everywhere. But it does not come from above. It is born within. Nearly every living thing here glows, not by reflection, but by invention. Bioluminescence, the chemical light of creatures who learn to survive, not by seeing, but by being seen. It begins with a flicker, a pulse of blue, a rhythmic flash in the dark, an invitation, a warning, a trick. And thus the game begins. Let's meet the players. The anglerfish, perhaps the abyss's most notorious ambassador. Its body is limp and jelly-like, its muscles barely developed. After all, down here, why waste energy on chasing prey when you can simply lure it in? A glowing bulb, a dangling filament, sways above its mouth like a hypnotist's pendant. The light is false hope, a sun in miniature, and when the curious draw near, its jaw unhinges, revealing a mouthful of translucent fangs that bend inward, offering no way back. Its stomach stretches to absurd proportions. It can consume prey twice its size and digest it slowly in patient starvation. Further along, the dragonfish glides through the black, a shadow within a shadow. Its skin is so dark, it absorbs 99.95% of all light, including infrared. It is not invisible. It is undetectable. This creature doesn't just see in the dark. It generates its own infrared light, like a sniper's scope, to stalk prey without being seen. Its teeth, bizarrely, are transparent, ensuring no reflective glint gives it away. A hunter, cloaked in anti-light, with fangs you can't see until they're already buried deep. Then comes the gulper eel, a ribbon of muscle and mystery. Its tail whips long and thin, but its head, its head, can balloon open like a parachute, It doesn't bite, it engulfs. Its stomach stretches to accommodate prey, larger than its own body. It has no bones as we know them, no ribs, only the ability to flex, to reshape, to become. It is less a predator than a mouth with purpose. Let us slow down now. The vampire squid floats nearby, a misnamed enigma, not a true squid, not a true vampire, but a relic from a time when the ocean was younger. Its cloak-like webbing connects its arms like a creature wrapped in its own wings. It does not chase, it drifts. When threatened, it does not run. It releases a swirling cloud of bioluminescent mucus, a glowing ghost of itself, and vanishes silently into the murk. A creature from mythology, living where mythology cannot survive. Mating, down here, is its own horror story. The abyssal anglerfish, for example, solves the problem of finding a partner by fusing. The male, often the size of a paperclip, attaches to the female's body and slowly melts into her. His skin dissolves, his organs vanish. He becomes a permanent appendage, a living sperm bank, sharing her blood supply until he is nothing but a genetic tool. One body, two souls, zero boundaries. It is romance, rewritten by necessity. Even among invertebrates, the innovations border on the absurd. Transparent crustaceans, amphipods larger than rats, sea cucumbers that swim through the water with wing-like fins like drifting ghosts. There are worms with glowing jaws and jellyfish that blink like coded messages from alien ships. And amid all this, marine snow, the steady, endless rain of organic matter from above, dead plankton, fish poop, scales, skin, carbon dust. It falls gently, continuously, a quiet, dirty blizzard of death from the world we know. And in that snow, these creatures feed, they clean, they recycle. Life here doesn't waste. It repurposes the end into a new beginning. Sometimes, though, we see things that defy description. Creatures caught once on a grainy deep-sea camera, never again. Pale beings with gelatinous wings and no eyes. Soft, amorphous predators that morph shape like spilled ink. A squid with 10-meter arms and photophores that blink in time like a silent symphony. These are not just animals. They are suggestions of life, like the ocean is dreaming them. Some scientists estimate we have discovered less than 10% of the species living below 6,000 meters. The rest, unseen, unnamed, unimaginable. And still, these creatures persist. Under pressures 1,000 times greater than the surface, where water could crush a human skull like paper, they thrive. They don't resist the weight, they adapt to it. Their bodies are soft, their structures minimal, their strategies honed over eons. They've learned to survive, not in spite of darkness, but because of it. In the deep, beauty is not symmetry. It is survival. It is glowing when nothing glows. It is fusing with a mate, becoming a lure, blinking in code, feasting on detritus, and thriving where no god thought to look. These creatures are alien. They are terrifying. They are delicate. They are victorious. They are the answers to the question no one thought to ask. What becomes of life when the sun is no longer part of the equation? Section 10. The water that burns. Superheated abyssal springs. It begins with a whisper beneath the sea floor. Not a sound, but a pressure. Not a voice, but a force. And then, suddenly, eruption. At the deepest stretches of the ocean, along the edges of tectonic boundaries, there are chimneys that breathe. They do not inhale, only exhale. But what they release is not air, it's fury. These are the hydrothermal vents, towers of blackened minerals. They rise from the seafloor like alien spires, each one a wound in the Earth's crust, leaking the planet's molten blood. The water that emerges from them is no ordinary water. It is superheated, up to 400 degrees, yet remains liquid, kept from boiling by the crushing pressure of miles of ocean above. This water is laced with metals, sulfur, and volcanic chemicals, poisonous, scalding, and utterly lethal to most known life. And yet, it is here, in this impossible place, that life blooms with abandon. Around the vents, amid the swirling black plumes, vast colonies of life cluster, unlike anything found elsewhere on Earth. Imagine a field of tall white towers swaying gently, not coral, not stone, but tube worms, some growing over 6 feet long, anchored to rock like sentinels. They have no mouths, no eyes, no stomachs, yet they thrive. Inside their ivory casings, symbiotic bacteria convert the vent's chemical brew into sustenance, chemosynthesis, life from poison. The worms simply host the alchemists. It is not predation, it is not consumption, it is partnership, and the worms are not alone. Giant clams with iridescent blue lips, blind crabs with delicate sensors on their claws, ghostly shrimp that see with backs instead of eyes, all gather at these towers, living in a heat that should kill them, feeding off sulfur and iron, surviving not because of the sun, but without it. In every other ecosystem on Earth, life is a branch that leads eventually to photosynthesis, to the sun, to light. But here, in the abyss, life rewrites the rulebook. And the vents themselves, they are not still. They hiss, they pulse, some collapse within years, only to rise again. This landscape is dynamic, a volcanic wilderness beneath the sea, ever-changing, ever-birthing. Scientists call them black smokers and white smokers, depending on the minerals they emit. Their chimneys are made not by hand, but by nature's own plumbing, minerals depositing out of superheated water, layer by layer, like coral reefs born of fire. And between these smokers, the ocean bed steams with hidden heat. It's as if the Earth's nervous system pulses here, raw, open, and ancient. But what makes this even more profound is not just that life exists here, it's that it may have begun here. Some researchers believe hydrothermal vents were Earth's original cradle, not tide pools under sunlight, but shadowed chimneys under pressure. Here, in this heat and chemistry, simple molecules may have linked together. Here, cells may have first stirred. Here, life may have emerged, not in light, but in darkness. That would mean the story of life, our story, did not begin with the sun. It began in fire, in metal, in poison, and still, these vents surprise us. New ones are discovered every year. Each one offers new creatures, new mysteries. Some vents emit methane instead of sulfides, forming cold seeps where entirely different ecosystems arise. Others form brine pools, lakes beneath the ocean, with salinity so dense that creatures fall into them and do not return. These underwater lakes ripple and shimmer, yet are utterly alien, with life skimming their surfaces like insects over a toxic mirror. And even now, when deep-diving submarines return from the abyssal plains, they sometimes carry footage of things we cannot explain. Creatures with mirrored skin, jellyfish that blink in Morse code, tentacled things that drift like folded fabric only to unfurl in an explosion of shape and color. This is not the deep sea we imagined as children. It is not empty, not barren. It is a realm of pressure-forged biology where the impossible becomes home, and where life, far from extinguished by darkness and heat, has instead been born again. Down here, the world is inverted. Heat is nourishment, darkness is shelter, poison is power, and life is patient. Life is inventive. Life is relentless. It starts with a number, 100 times the pressure of the air you're breathing now. That's what crushes every square inch of your body if you stand at the bottom of the Mariana Trench. If you tried to dive there, unprotected, your body would implode instantly, your lungs flattened, your skull compressed like an eggshell underfoot. And yet, somehow, impossibly, this is home to some. At 11 kilometers deep, beneath a crushing lid of water, is a world with no sunlight, no plants, no easy energy, and still, life persists. It adapts, it innovates. Down here, pressure is not the enemy, it is the sculptor. Let's begin with a creature that shouldn't exist at all, the Hadal snailfish. It is soft, pale, gelatinous. It has no scales, no defenses, no aggression, and yet it lives in the trench's deepest grooves, fluttering like a ghost just above the seabed. Its bones are barely bones, more like cartilage, and its body is a marvel of biochemical engineering. Its cells are filled with TMAO, a molecule that stabilizes proteins under immense pressure. The deeper you go, the more TMAO you need. For humans, it's the compound that makes fish smell fishy. But for deep-sea life, it's the difference between life and liquefaction. The snailfish eats tiny crustaceans and marine snow. It glows faintly with bioluminescence, a shimmer like a memory in the dark. It is slow, gentle, almost tender, and it has no business being alive at all by our rules. But these are not our rules. Down here, the laws of biology warp. Where we need skeletons, these creatures turn boneless. Where we breathe oxygen, they use sulfur. Where we see with light, they see with vibration, pressure, electric current. You will not find fierce predators or lush food chains. You will find a different kind of intelligence, a different kind of resilience. The amphipods, shrimp-like scavengers with transparent shells, have aluminum in their bodies, scraped from the seabed. They wear the earth like armor. The cusk eels, long and slender, navigate by sensing slight temperature gradients, where 1 degree of warmth might mean the difference between survival and starvation. Some deep-dwelling jellyfish stretch their tentacles 10 meters long, trailing through the water like drifting constellations. And all of them operate under a shared principle: move slow, conserve, endure. But let us pause, because in this extreme world, even time moves differently. Many deep-sea creatures live unthinkably long lives, centuries, maybe longer. The Greenland shark, a shallower cousin to the Hadal world, can live over 400 years. Imagine what lies beneath, in places no harpoon or hook has ever reached. Without sunlight, seasons don't matter. Without seasons, aging slows. Metabolism drops. Reproduction is infrequent. Mutation is rare. Down here, evolution is not a sprint. It is a glacial drift. And the results are beings unlike any we know, survivors shaped by eternity. Some creatures of the trench remain entirely unknown, just blips on sonar, movements caught on remote cameras, disturbances in the sediment, unseen shapes that elude the light. There's the story of a Japanese submersible that detected something enormous, larger than any recorded fish, hovering at 10,000 meters. The sonar could not resolve it. The video caught only shadow, but the trench kept it secret. There's also a creature they call the faceless fish, first discovered in 1873, then lost for over a century. It has no visible eyes, no mouth apparent on its smooth face, only a body adapted to a world that doesn't need faces. We try to categorize them, classify them, place them in some taxonomic tree. But the truth is, these creatures are outliers, edge cases, rule breakers. They exist because evolution is not always predictable, because sometimes, given enough pressure, life becomes something else entirely. And this relentless shape-shifting survival has consequences beyond biology. The extreme environments of the deep are now studied for insights into space travel. What can live here might also live on Europa, or Enceladus, or beneath the ice caps of Mars. The adaptations of deep-sea organisms inspire new materials, medical breakthroughs, even robotic design. Their ability to withstand pressure, process toxins, generate light, all are blueprints for future technologies. Some researchers even believe the genetics of these trench creatures could help slow aging, cure disease, or enhance human endurance. Because in every cell that survives the trench is a manual for how to resist the impossible. But perhaps the most poetic truth is this: these creatures live in a world that never knew us. No boat has cast a shadow above them, no voice, no footstep, no war or civilization. They live as they have for eons, untouched. And so, to study them is not just to look at strange fish. It is to peer back in time, to glimpse what Earth might have been before we ever arrived, to witness forms shaped not by conquest or dominance, but by gravity, silence, and pressure. And here's what they teach us: that fragility can be strength, that survival is not always loud or aggressive, that even in the darkest places, life finds a way to soften, to endure, to adapt. The pressure that would destroy us nurtures them. The dark that would blind us guides them. They are the quiet champions of biology, creatures that should not exist, but do. And in their strange, gentle persistence, they remind us of one thing: life is not what we think it is. It is more fluid, more daring, more humble than we imagined. And it may be, in the grand silence of the trench, that the greatest intelligence is the one that simply endures. You're drifting above a place that shouldn't exist. No life, no sound, no warmth, just silence. Deep, absolute, eternal silence. But beneath that stillness, the earth is at war with itself. At the very bottom of the ocean, where light cannot go and pressure crushes everything it touches, something is always moving, trembling, colliding, because this is not just the deepest part of our world, it is also the most violent. We begin with a word that defines this place: subduction. This is where Earth's great tectonic plates meet, and one is forced beneath the other, sliding silently into the mantle, melting, bending, breaking. It happens slowly, centimeters per year, yet with consequences that span millennia. And it is here, in these Hadal trenches, that subduction carves the ocean floor into chasms miles deep, like scars across the skin of the earth. The Mariana Trench, the Kuril-Kamchatka Trench, the Tonga Trench, these are not just voids, they are the front lines of a hidden battlefield. Imagine the Earth's crust as a patchwork quilt, thick plates of rock floating atop a sea of molten metal. They shift, buckle, grind. When they collide, they either rise into mountain ranges or sink into trenches. Where they sink, subduction begins. One plate is dragged downward, carrying with it ancient sediments, dead marine life, carbon, and water deep into the earth. And what happens next, thousands of meters below your feet, is one of the most powerful geological processes in existence. Earthquakes, tsunamis, volcanic chains, they are born here. Because when enough pressure builds at these junctions, the plates don't just slip, they snap. That sudden rupture sends shockwaves upward, through rock, through water, shaking coastlines thousands of kilometers away. In 2004, such a rupture occurred off the coast of Sumatra. A 9.1 magnitude earthquake shook the seafloor, lifting it by meters in seconds. What followed was a tsunami that killed more than 230,000 people across 14 countries, all from a single movement, deep in the ocean's trench. And yet, we barely understand this process. Why do some quakes trigger tsunamis and others don't? Why do some trenches build stress for centuries before snapping, while others rupture more frequently. Our instruments, seismographs, ocean bottom sensors, are few and far between. The deep is too vast, too cold, too crushing for most technology to survive long, so the battlefield rages in secret. Only the consequences reach us. But subduction doesn't just move Earth's surface, it builds it. As one plate dives under another, it melts. That molten rock rises again, creating chains of volcanoes above. This is why the deepest trenches often sit beside towering volcanic arcs. The Andes, the Aleutians, the islands of Japan and Indonesia. Fire and water, destruction and creation are inseparable here. In fact, the Pacific Ocean's Ring of Fire is a result of this endless cycle. 25,000 miles of volcanic tension circling the ocean basin, constantly reshaping the world we walk on. There's another secret carried down into the trenches, one even more vital: carbon. As sediments and dead organisms sink with the subducting plate, carbon is dragged deep into the mantle. Some of it is locked away for millions of years. Some of it returns, released through volcanic eruptions. This process, called the deep carbon cycle, is part of what keeps Earth habitable. It helps regulate atmospheric CO2 over geological time. Without it, we might become Venus, scorched by Runa, way heat, or Mars, frozen in a carbonless silence. So, in a strange roundabout way, the ocean trenches help keep the air breathable. The deepest scars on Earth keep life going at the surface. And perhaps most haunting of all, these trench zones are also where planets die and are reborn. Every year, a few centimeters of the Pacific Plate slides beneath the Philippine Plate, beneath Japan, beneath the Aleutians. Over millions of years, entire ocean basins vanish, swallowed by the Earth. This has happened before. The ancient Tethys Ocean, once larger than the Atlantic, was slowly consumed by subduction. All that remains now is the Mediterranean Sea. The Iapetus Ocean, long gone, gave rise to the Appalachian Mountains. Even now, the Pacific Ocean itself is shrinking, being devoured at its edges by deep trenches. One day, it may disappear entirely. What rises in its place? That's for time to decide. We call these places dead zones, but in truth, they are the engine rooms of the planet. Every earthquake, every volcano, every mountain range owes something to the trenches, and yet we know so little. We've explored Mars more than we've explored the subduction zones of Earth. We send rovers to Jupiter's moons, yet only a handful of missions have visited the deep trenches where Earth remakes itself. Because it's hard, dangerous, expensive, and maybe, just maybe, because part of us doesn't want to look too closely. To stare into these vast wounds is to confront the truth that our continents are not permanent, that our mountains are only temporary pauses in a cycle of rise and fall, that even the ground we walk on is floating, fragile, fleeting. The Earth is not still. It shifts, twists, consumes, erupts, and it always has. So next time you stand on a mountain or sit safely by the sea, remember the silent war happening far beneath you. Plates grinding, rocks breaking, tension rising in invisible walls 11 kilometers deep. One day, maybe in a year, maybe in a century, that stress may snap, and a wave born in the darkest trench could reach the light. Beneath the shimmer of waves, beneath the surface churn and the twilight zones, beyond the reach of sun and the whispers of wind, there lies a world untouched, not just by human hands, but by human thought. Because no map, no measurement, no myth has ever truly captured what lies 11 kilometers beneath the ocean. We began with light, the sunlit shallows where life dances in colors we can see, and coral cities bloom like underwater galaxies, where fish glide like living jewels and everything feels familiar, comforting, even knowable. Then we sank deeper, through twilight and midnight, through bioluminescent realms and forests of darkness, through pressure and silence and cold. And as we dropped, the world turned stranger, softer, colder, unbelievable. We saw creatures that glow with no fire, whose bodies bend under gravity's boot, who live without sunlight, without eyes, without air. We saw entire ecosystems balanced on chemical trickles from the Earth's wounds, life thriving on hydrothermal vents, never having known the sky. We passed sunken ships and lost dreams, the Titanic resting in rust, forgotten submarines like tombs of ambition, cargo that never reached shore, messages that never made it home. And we kept sinking, into pressure so crushing it can crumple steel, into cold so deep it defies thermometers, into darkness so ancient it has no beginning. We reached trenches that could swallow Everest whole, valleys where no sound echoes and no time seems to pass. And in these depths, we found movement, plates colliding, earthquakes roaring in silence, volcanoes blooming under black oceans, carbon, heat, life, all recycling in a silent ballet billions of years old. These aren't just geological curiosities. These are the pulse of the planet. Without them, continents wouldn't rise, atmospheres wouldn't regulate, life, as we know it, couldn't breathe. The abyss isn't just deep, it's essential. And yet, so little is known. We've mapped less than 25% of the ocean floor with any detail. There are more detailed maps of Mars and the Moon than of Earth's deepest basins. We send probes to the stars, build telescopes to stare into galaxies, but the greatest alien world may be just beneath our feet. We've only visited the bottom of the Mariana Trench a handful of times, each journey costly, dangerous, lonely. James Cameron once said descending to the trench felt like visiting another planet, and he was right. Not because it was lifeless, but because it made us feel small. And perhaps that's the real reason we've looked away. Because to face the deep is to admit how little we control. We build cities and towers and satellites. We predict weather and model economies and cure disease. But we can't stop the pressure of the sea. We can't pause a plate from shifting. We can't make the deep reveal its secrets. We can only watch. We can only wonder. Still, something stirs. More than ever, explorers, scientists, engineers are turning their eyes downward. New submersibles that can survive the pressure. New sonar that can map the hidden terrain. New eyes, mechanical and human, peering into the abyss. Because down there may lie the answers to questions we haven't even asked. How did life begin? What sustains it without sunlight? Could similar oceans exist beneath the ice of Europa or Enceladus? Could the deep teach us to live with less, to adapt, to evolve? And more pressingly, can we protect what we don't understand? As climate shifts and industries expand, the deep ocean, once too remote to touch, now finds itself under threat. Mining companies eye the rich metals of the abyssal plains. Fishing fleets probe deeper for dwindling stocks. Pollution, noise, microplastics are already falling into trenches once thought unreachable. We must ask, is curiosity enough? Or will we act only when the silence breaks? Because in the end, this isn't just about the ocean. It's about Earth itself and what it means to belong to it, to live on a planet still alive, still changing, still deeper than we know, to breathe air made possible by unseen cycles, to walk on crust floating atop an unknowable sea, and to look at the horizon not just as an edge, but as a beginning. So the next time you stand at the beach, let the sound of the waves remind you that below there is a world older than mountains, darker than night, and more mysterious than space. A place not hostile but untamed, not empty but full of stories we've barely begun to hear. And when you dip your foot into the ocean, remember, you're not just touching water, you're brushing the edge of a kingdom 11 kilometers deep.